Australia relies on freight to keep the economy moving. The transport and logistics sectors of Australian economy are estimated to contribute 14.5% of the GDP. Therefore, the strategic planning and performance of freight are crucial in economic activity through investment in warehousing and transportation. But how do we know where freight is moving to, from, and around Australia? How they are being moved, and if there are any physical bottlenecks blocking an efficient movement of freight? How can freight operators plan out their route to avoid worsening the traffic conditions? That brings us to our goal of having a fairly accurate visualizations of where freight goes. Freight operators and government want to know what and where are the opportunities for freight movements to be more efficient. The challenge is, most datasets such as estimates of freight traveling to and from a highway or planned roadworks and rest stop for truck drivers are static data. They are not updated daily and they are not accurately providing a predictive model for truck drivers to plan out their routes. Throughout Govhack weekend in our brainstorming sessions, we realized one of the data that gets updated constantly and daily when there's traffic coming through them is tolls. The fact is, most large-sized commercial vehicles use toll highway. They do not have an option to use all other road networks, but instead only large highways with multiple lanes and generous height clearance for them to move tons of goods across Australia. The question apparently then comes to mind: how do we utilize toll data along with the National Freight Data Hub to create a predictive model in estimating traffic flow characteristics in highway usage in Australia? We propose SmartFreight, a visualization tool that utilizes toll data and National Freight Data Hub dataset to compute the most efficient route planning for freight operators. Let's take an example of New South Wales toll road data below to illustrate our point. SmartFreight uses information from Google or Apple Map to lay out its interactive mapping services. We then use National Freight Data Hub datasets to identify heavy vehicle rest areas and major roadworks, as well as Roadworks Endpoint New South Wales API to identify relevant traffic hazards such as incidents, fires, and floods. The visualization tool then utilizes data from tolls such as previous vehicles enter time, exit time, and travel time, as well as the length of the toll used to compute the average travel speed of the vehicle to determine what would be the best route for freight operators. By categorizing and aggregating cars that pass on a specific connection at a given time, a practical technique to determine traffic flow characteristics of tollways was developed. Computer language then might be used to quickly implement the suggested methodology. The significance is that it explored different types of application scenarios for converted data for tolled highways and presented a core toll data transform method. That's SmartFreight by Osar.